Below shows how two resistors can be connected in a series or in a parallel to a 12-volt cell. The resistors are identical. Calculate the potential difference across each resistor when the lamp is connected in a series and a parallel. Okay, so that's quite straightforward. So when we have a series, we know that the voltage is split equally. So that's going to be 6. That's going to be 6 volts. So in the series, resistors have 6 volts. Okay. In parallel. Okay, so in parallel, the potential difference is same across 12 volts, 12 volts. If we have total VT equals to V1, say if this is 12 volts, V1 is 12 volts, and the V2 is 12 volts. So we can say in parallel, circuit parallel resistors will have 12 volts. Okay. Next question, B. Okay, it's a bit all over the place here. That's B over here. Give one disadvantage of connecting lamps in a series to run parallel. Okay. Okay. So we can say less potential difference. Also, we can say that if a lamp doesn't work in a series circuit, rest of the lamps won't work either. Rest of lamps won't work either. All right, question number C. Okay, figure 5 shows how an ammeter can be used to measure the current flowing through the battery for the same circuit. So we got a over here. The reading on the ammeter is 1.6. So 1.6. It says add an ammeter to figure 5 to show how you can measure the current through the resistor R2. So we can use over here, or we can put an ammeter. We have to put it there just to make sure we can measure the current. That's done over here. And last question, the resistors are identical. State the current through R2. Okay, the resistors are identical. State the resistors R2. So we know that the total resistance equal is actually, when it comes to these two over here, we know that the resistors will the current has to split between the two. Okay, so if the current over here is 1.6, we got 1.6 amps. We're going to divide it by 2. We know it's going to be 0.8 amps.